Hey, all right, this time it looks like we're doing the Desmos Unit 7, Lesson 10 practice. I've got it here on paper. You might be doing it in your book. You might be working online. Should be the same questions either way. Sorry, I look so shadowy. The light in this room isn't the best for this, but you don't really need to see me. You need to see this anyways, right? So let's get started. We got select all of the expressions that are equivalent to 3 times the quantity x minus 2 plus 5. We could simplify this expression, then we could see what it is a little bit easier, right? So if you distribute this 3, you get 3x minus 6, but then you got plus 5. Negative 6 plus 5 is negative 1. So the whole thing is equal to 3x minus 1 or 3x plus negative 1. Okay, so I'd say that one right there works. That one's pretty obvious. And this one right here is also the same thing. This is 3x plus negative 1, just with the negative 1 and the 3x moved around. This one, on the other hand, is not. This one, the 1 is positive and the 3x is negative, so those aren't the same thing. Here, if you were to distribute that 3, you get 3x minus 3. That's not the same. And clearly 3x plus 3 is also not the same. So I think just those two that I checked are going to be the way to go. All right, prisms. That's a shape that hopefully we've been talking about in class lately. A prism is a three-dimensional object that has two faces, also referred to as bases, on opposite ends of the shape from each other that have to be parallel, like this. They can't, like, they're not going to touch. They can't be sort of angled at each other so that they would touch if they continued on. An easy way to think about it is think of some cylindrical object you're familiar with, like a soda can. The top where you drink from and the bottom where it sits on. They're not perfectly flat, but if they were, they would be parallel bases. And so we tend to think of that as a prism. A cylinder is a type of prism. So if you can identify two bases that are parallel from each other, and then as long as the other sides are essentially straight up and down, you got yourself a prism. So here, I don't think in this shape, I can't identify two sides, two bases that are opposite each other and parallel. Like this front slanted side isn't parallel to any other side. This bottom base here, the square, it doesn't have another square like on the other side that it's parallel to. So, oh wait. Ooh, I almost messed that up. This one is a prism. So sometimes these are tricky, even for me. This front triangle, actually, whenever the prism is oriented, that means the way it's sitting, in such a way that the parallel bases are in the very front and the very back. To me, it's harder to see. It's easier to see when they're on top and bottom. But if I highlight that front triangle and that back triangle, now we can actually see that there's these two identical parallel triangles that are making up the front and the back of this shape. And that's what's going to classify this as a prism for us. So almost messed that one up. See, this one's easier to see for me because the parallel bases that make it a prism are on the top and bottom. And for whatever reason, I don't know if it's the same for you as it is for me, but my brain works in such a way that it's just a lot easier to see them when the parallel bases are on the top and the bottom rather than the front and the back. So this one's not going to work because that top and that bottom, yeah, they're parallel, but they're not identical. That top one is smaller and it's making all the other sides have to like come in at a slant toward each other, and that's not a prism. This one here, this pyramid, is essentially the exact same thing as this, just more extreme, right? Now the top is a tiny little point. So same reasoning than why the pyramid doesn't work. This one, on the other hand, is very similar to the first one. The parallel identical bases that make it a prism are this front triangle and that back triangle back there here and here. And so I would say the three that I shaded in the bases on are going to be your prisms. All right, let's move on. It says for each prism, shade one of the bases, kind of like what I've been doing up there. Okay. Well, I don't know if it's like this on the one where you do it online rather than in the book, but like it's already done. They shaded the bases. I mean, I can shade on their shading, I guess. But I mean, each one of these already has, or oh, maybe they meant to shade one of the bases up here. Maybe they're talking about these. Oh, well, if that's the case, I mean, I kind of already outlined each of the bases on the prisms. Good enough, right? So, but if you're doing it, yeah, pick one of the sides that I outlined for each one of these and just shade it in. Okay, so I'm going to move on to here. It says, here are 3 prisms with the same base, okay? Each one of them has a 2 by 3 base because it's labeled here on prism A. And then they're telling me that prism B and prism C have the same base. So this is also 2 right here. And this is 3 running back here. And then let's get a little closer. And then this is also a 2 right here in the front. And then 3 running along back there. But they're just different heights, right? So these are like boxes that are the same size on the bottom, but just one's kind of short, one's kind of medium, and one's really tall. And so we look at the volume. Well, the volume is how much each box can hold. Obviously, this one's going to be able to hold the least. This one will be able to hold the medium amount, and this one will be able to hold the most. Well, this one, since the base is the same as the base of this one, but this one is height 1, and this one has height 3, then this box is literally exactly the same as just having 3 of these stacked on top of each other. And so this one is going to hold 3 times as much as that one. And then for the very same reason, look, this one has height of 9 compared to this one's height of 3. So this one is exactly like having 3 of these stacked on top of each other. And so this one is going to hold 3 times as much as that. And then therefore this one will hold 9 times as much as that original one. Finding the volume of any prism is find the volume of the base, sorry, the area of the base. So in this case, 2 times 3 to find the area of that rectangular base, and then multiply it by the height. And so it's kind of like you're stacking that base on top of each other to see how many times you can stack it. We probably watched a video in class where the mice were like stacking the cookies, as they called biscuits. That's what they're trying to show you. The biscuit, one biscuit is like the base, and then you stack it to see how many you can fit. So 2 times 3 times 1 for the first one is just going to be 6 cubic units. I'm not going to write it because it already says it there for me, but volume is always in cubic units, little cubes. How many little cubes can you fit in there? All right, so this one's going to be 2 times 3 for the area of the base, and then times another 3 for that height. So let's see here, 2 times 3 is 6, times 3 is 18 cubic units. So 18 little cubes could fit in that one. And then the last one is going to be 2 times 3 again, but this time times 9. Let's see here, 6 times 9 is 54. And like I said, 18 is 3 times bigger than 6, and 54 is 3 times bigger than 18. The relationship I was talking about earlier, I think we got it. Okay, so now you just watched me get the volume for 3 rectangular prisms, right? So that makes me feel like you should be able to do this one without my help. And you could probably do this one as well, as long as you know how to find the area of the base. So remember, step 1 is find the area of the base. And in this case, the base is a triangle instead of a rectangle. So you got to know how to find the area of a triangle. Well, finding the area of a triangle is the base of the triangle, and that's different. When I say the base of the prism, I'm talking about this whole orange triangle. But then when I'm talking about the base of the triangle, I'm talking about just that 6. So the base of the triangle times the height of the triangle, so 6 times 8. But then you divide it by 2, because you should think of it as like if this triangle was part of a rectangle, and then you cut that rectangle in half, you'd wind up with 2 triangles, right? So 6 times 8 gets you the area of a rectangle if it was like that. And then you want to divide that by 2 or times it by 1/2 because you only have half of it. Like you only have half of a sandwich if you cut it into triangles. So 6 times 8, do that first, and then divide by 2. 6 times 8 is 48. Divided by 2 is 24. So I'm giving you the first part. That's the area of the base. Now you just got to multiply by the height. And I'm going to leave that for you to do. You got 2 numbers here. Which one's the height? And my advice for you is to think about it like height usually means up and down, right? So I want you to envision this prism. If somebody turned it up so it's standing up tall ways, then what number is the height? Because there is a number in here that you don't need at all. It's just in there to trick you. Now I'll let you figure out which one's which. Okay, so this is only step 1. Finish this one, please. All right, the next part. We got determine the measure of each angle. We did a bunch of these algebraically. Remember, the rule is that all these angles that go around a central point, their degree measures add up to, I hope you already know it, it is 360. So we know that. We know they all have to add up to 360. We're probably also going to need the fact that these angles here, oops, I moved that too much. These angles here on top of this line and on bottom, these ones here, they all add up to 180, right? And then all the ones on the other side of the line also add up to 180. And then we might need our vertical lines. Well, no, I'm not sure we're going to need vertical lines on this one. Well, yeah, we might. So vertical lines, vertical angles happen wherever there's 2 crossing lines in a diagram. And it took my eyes a second to be able to find where the crossing lines were. But this orange line that I already highlighted and this one that I'm going to highlight as green are 2 intersecting lines. And so the angles from green to orange here and the angle from green to orange here have to be equal. So these are all some different facts that we could use to help us along the way. Well, the first one we're supposed to be able to figure out is A. What could we do? Oh, it's going to involve the green line. The one that I highlighted in green, all the angles on one side of it have to add up to 180, and all the angles on the other side also have to add up to 180. And see how the 110 and the angle A make up one whole side of the green line? So that means they have to add up to 180. So you get 110 plus A equals 180. That's going to be our first fact that we can use. And you've done these before. You've solved them as equations. Subtract 110 from both sides. You would get A equals 70 degrees. Okay. So now can we do B? Well, now that we know A is 70, now we can look at all the angles on the upper side of this orange line. We have a 65, a 70, and an unknown, and they all have to add up to 180 together. So you're going to have 65 plus 70. Oh, this brown one's about done. Grab this one. 65 plus 70 plus that unknown B angle equals 180. I want you to solve that one this time. And then the last one, C, well, there's a few different ways you could go about figuring out C. You could use the fact that now that you know what B is, that angle plus this 65 plus C plus 20 all have to add up to 180 because they're all making up one side of that green line. Or you could use vertical angles. Remember, from orange to green here, where it says C and 20, has to be equal to orange to green up here, where it's 70. So 70 equals 20 plus C. So maybe you could figure out what C is based on that. Okay, so I'll let you figure out B and C without any more help from me on that one. And let's look at Melissa wants to buy a $25 hat. The sales tax in her state is 6.25%. How much will Melissa spend on the hat, including the tax? Okay, so we need to take $25 and increase it by 6.25%. We could either do that by one multiplication, or we could do it with two multiplications. The way most people do it, I think, is they find 6.25% of $25 and then they add it on. That's actually not my favorite way, but that's the way we'll do it right now. So if we want to know 6.25% of $25, we need to multiply it by 6.25%, but in its decimal form, not as a percent. So I'm going to write 6.25 a little bit bigger right over here so I can remind you of something. 6.25%. When you want to turn this into a decimal so you can use it in your calculations, you move that decimal point 2 spaces to the left. So when we move the decimal point 1 space, it goes from being between the 6 and the 2 to now in front of the 6. So we would have 0.625, but we only moved it 1 space. We're supposed to move it 2. So let's move it 1 more space. And it winds up here, but there's like this gap, right? We fill that gap with the 0. And so if the decimal point's right here now, we have 0.0625. And now we don't need the percent symbol anymore. That's the decimal form. So if we take 25 and times it by 0.0625, that's going to get us 6% of $25, which should be like, I don't know, maybe $2, probably not even $2, like $1 something. So let's see. What are we doing? 25 times 0.0625. 1.5625. Now that's kind of weird because we're doing dollars and cents right now, right? So if we cut that last part off, we got $1.56. We should probably leave it as $1.56 because this 2 right here is small. If this 2 were something larger, like let's say a 7, and it said 1.567, then I would think maybe we would need to round $1.56 up to the next number, which would be $1.57. But I think let's keep this down to $1.56. All right, so this equals $1.56. But that's just the tax amount. They want to know how much are they going to spend total. So you should finish this question off by doing $25 plus that tax amount of $1.56. All right, the last part is the Explorer. Remember, the general rule on the Explorer is you don't have to always be able to fully solve and finish them because sometimes they're tough, but you got to show me you at least tried it. You messed with it, you punched in some numbers, you gave it a shot. So it says use the whole numbers between 1 and 9 without repeating to create 2 prisms with the same volume. Wow. Okay, so I guess they want rectangular prisms to start off with. They didn't really specify that, but I assume that based on the drawing there. So maybe on your first one, you probably don't want to use all small numbers on one because then you're going to be stuck with all big numbers on the other one, and there's no way they'll multiply to make the same thing. So maybe you do one where you have like a small, a medium, and a big, and then you try to use another small, medium, big on the other one to see if it matches out. That would be my first idea. So what if we did like 1, 4, and 9? No, I'm gonna go 8. 1, 4, and 8. What if I did 1, 4, 8? Now its volume would be 1 times 4 is 4, and then times 8 is 32. So if I could just come up with 3 other numbers that I haven't used, where when you multiply them you get 32, then I'm good. 2 times 8, that doesn't work because you're not allowed to reuse the same numbers. 2 times 4 times 4, that doesn't work because you're not allowed to reuse them. So this combination might not work, but that's okay. mess around with it. Your job is to at least try it, think your way through it, try a couple combinations. If you can't get it after a couple minutes, it's okay to stop. All right, I'll see you next time.